So every exponential function takes the form y equals a times b raised to some power. You might see that variable x actually be a t because it usually represents a time unit, but either way your variable is up in your exponent. A is your starting amount and b is the growth or decay factor. It will be growth if the b value is greater than 1, and it'll be decay if it's somewhere between 0 and 1. Determining the b value can be kind of the challenge at times for a lot of students. In a story problem, if you see the following phrase, increasing by 22% each week, well, in this case, your b value has to equal 1 plus that 22%. So in other words, your b value is 1 plus 0.22 or 1.22. Going back to that original slide here, b, we know, is our growth or decay factor. It's the number we're multiplying our a value by to determine the new amount. So a is what we start with, and then we multiply by b x number of times, depending on how many times it's growing or decaying by that certain percentage. So if something was increasing by 22% each week, the b value that we use, it would be 1.22. If something was increasing by 3/5 of its original amount each year, then our b value would be 1 plus 3/5, or 5/5 plus 3/5, which equals 8/5. You could use a decimal there, but to me fractions are easier. So going back, in that situation, our b value would be 8/5, because if I multiply my a value, my starting amount, if I take my starting amount and I multiply it by a b value of 8/5 over and over and over again, it's going to grow by that 3/5 each. I think that was a year, I said. Yes. Okay. Now, decay can sometimes be a little trickier. Let's say something was decreasing by 7% each month. Well, in that case, my b value is going to be 1 minus 7%, or 1 minus 0.07, or 0.93. Because if something is decreasing by 7%, it's losing 7% of what it had. Well, it had 100% to begin with, because 100% is all of something. If I take away 7% from what I had, I'm taking away 7% from 100%, which would be 93%, or 0.93. Either way, to determine your b value, when something is decreasing, you will do 1 minus however much it is decreasing by. So in this case, if this was our problem, coming back to the original equation, we would use 0.93 as our b value. We take our starting amount, whatever number that is, times 0.93 raised to some power. When you multiply something by 0.93, it's going to get smaller. That's what happens when you multiply by a number that is less than 1, or between 0 and 1. It's going to decrease. I can do the same sort of deal with a fraction. If something is decreasing, whoops, if something is decreasing by 1/3 of its original amount, my b value will be 1 minus 1/3, which equals 2/3. So if something says it's decreasing by 1/3 of its original each time, my b value that I would use would be this 2/3 amount. So in summary, to determine your b value, if something is growing, you do 1 plus how much it's growing by. If something is decreasing or decaying, you do 1 minus the amount it's decreasing by. Sometimes people might just say it's increasing by a factor of 1.8. Well, anytime they use the words increasing by a factor of 1.8, they're actually telling you the b value is 1.8, because they're essentially giving you the growth or decay factor. They're telling you what number it is. They're not telling you how much it's increasing by. They're just telling you how much that b value is. Hopefully this can help you.